Let's take a deeper look at one-point perspective and how to construct interior and exterior scenes using what we've learned so far. Let's consider an exterior scene like this street first. Now notice in the street that the buildings in the background are blocking the horizon, and therefore it's very hard to know where this horizon line should be placed. To find where our horizon line should be for these elements in the foreground, all we need to do is draw these orthogonal lines using our line tool here. And again, I've set mine to pixels so that I'm just drawing pixels on the layer. And I can follow these lines back into the distance to see where they match up. So I've drawn in a whole bunch of these orthogonal lines, and you can see that everything in the scene that is moving parallel to each other down this one street is meeting up at this point on this van here. Then I can show my horizon line layer, and I can move that down to match where the vanishing point for these elements of the scene is. You can see here how our scene is essentially made up of a series of boxes and shapes like we were drawing in our scenes in perspective before with those simple boxes. All of these can be drawn in perspective this way. The side of this building is essentially the side of a massive box, and within it these windows are each a box in their own right here. You can see all of these box shapes. Now the reason that I mentioned that these orthogonal lines apply and this vanishing point applies to the foreground is if we look at the town in the background here, you'll notice that these buildings are not following lines to the same vanishing point. And in fact, if we draw a number of lines here, we establish a new vanishing point over to the left hand side of the screen. If I remove some of the existing lines, you'll see what I mean. So there is now a new vanishing point here, and that is because these orthogonal lines and these orthogonal lines are pointing in a different direction, i.e. the buildings are aligned differently. So remember, orthogonal lines only tell us that these elements are all pointing in one direction. They're all moving in parallel with each other. These lines here are not moving in parallel with these lines. If we looked at a bird's eye view of our street, this street here would be heading down this direction, and then it turns at this stage. Okay, so we have different vanishing point because these parallel lines are facing a different direction. Now it still hits the same horizon line, but it's moved over to the left. Notice on this street how it's made up of three walls. This first wall has a vanishing point over here. The second wall has a vanishing point over to the left, and the third wall has a vanishing point that is off scene. And that is because none of these walls are aligned with each other. None of them are working in parallel. Now all of the objects that are on each wall are working in parallel with each other, so it's still very useful to draw these vanishing points, but because the walls are facing different directions, they're not running parallel to each other, the vanishing points do not meet up. Before we move into drawing a scene ourselves, let's consider how the height of the horizon line influences our scene. So we've established where this horizon line is thanks to the orthogonal lines and the point that they meet, the vanishing point. At the moment, the horizon line is right in the middle of my scene. Now, if I'm drawing a scene, the position of this horizon line is going to determine how much of the floor or how much of the ceiling or how much I'm looking up or how much I'm looking down within my scene. Let me just demonstrate that. If I grab everything together here and I move it up, you can see that the horizon line is moving up. Now these are still pointing back to that horizon line, so it's all still correct. But I can see a lot more of the ground of my scene. If I drew my horizon line lower down, it means that my scene would be primarily focused upwards through the buildings. So it's up to you when setting your horizon line height. Do you want it in the middle so that you get an even amount of ground space and space for the things that are above ground level, or do you want to see up into buildings or into a room, or do you want to see down onto the ground? It depends on where your focal point for the scene is going to be, and you're going to be drawing your horizon line first, so it's really important that you get that in the right place. So here, if the action was happening on the street, I would have my horizon line high, but for now, whenever we're drawing, I'm going to be drawing some buildings, so I'm going to keep my horizon line lower than halfway. So let's start drawing. The first thing, as I said, that we're going to draw in is that horizon line, just with a straight line. The second thing that we're going to do is decide where the vanishing point is going to be. And that vanishing point doesn't necessarily need to be right in the center of your scene. As we saw with the photos earlier, it can be anywhere within your scene, and that will create a different look. I'm going to do mine slightly off center just here. For reference, here's an example of a street with a vanishing point somewhere in the middle, where you can see equal amounts of both sides of the street. And here's an example of a street with the vanishing point leading towards the far right hand side, in this case, where you can see all the orthogonal lines are kind of leading down towards here. And in this case, you can see much more of this side of the street than you can this side. In fact, this side is completely occluded by this front face here. Now back to our scene. I'm going to quickly establish a grid using this vanishing point and the horizon line that I've set. This gives us a bunch of parallel lines receding into the distance. Next thing I'm going to do is define my street, so whereabouts the houses start and stop. So here is one house, for instance. I'm just going to draw the side view of it here, using the same perspective tools that we were looking at last time. So I've drawn a square front face, and then I will draw my back face. This is going to intersect somewhere here according to where this disappears in perspective. So I'm just going to grab my orthogonal line and draw a guide from there to here. And I can see that intersects nicely with that edge, so I can keep going. That's the base of my building. I'm just doing a draw through of the buildings. You won't necessarily need to do this for all of them. And I can guesstimate that this will be just above this line because of where this is disappearing in perspective there. That looks accurate enough. Now obviously we're not going to see the floor through this building, so you could just draw that front face if you wanted to. To be able to draw a triangular roof on this, on the gable wall, I need to be able to find the exact middle of the shape. We did this last time as well, so to do that I'm going to go back onto my orthogonal lines just to draw some guidelines. These are not orthogonal lines, they're just guidelines. So I'm drawing between each corner there, and that will find the perfect center of this house right there. And see the center of the house actually coincidentally runs along the vanishing point pretty much. If I project this line up then from the center, I can choose a point of the height on this, and from there I can draw in the roof. Now to find out where the top of this triangular roof goes, I just need to select this point, shift, and then select my vanishing point here, and that will draw the line of the roof as it recedes into the distance. And to find the edge of this is going to be a little trickier. For this I need to find the width of the back face of this building. Now thankfully I'd already drawn that orthogonal line back from here, so I know that it'll meet about here, come up to here, and I can project across there. Okay, so I've just constructed a cube there on the back. So from this corner I know that it's going to meet the roof somewhere in the center here, but I need to calculate the center, and again I can just use an X to find that central point. Just draw from each side, find where the lines intersect. This is awkwardly behind this line just by coincidence here. Draw up to here, and this is the point at which the roof will meet. So I can draw from here up to the roof line, and then from there across the top of the roof. Alright, so let's say that this street is all made of identical houses. To be able to find the size of the house across on this side of the street, I can just project lines across here using my guidelines, and I'm just holding shift to draw a line horizontally across, so I know this is going to be the depth of the house. So I'm just going to use one of these orthogonal lines as the distance the house is projected into the background, and use these two lines here to dictate the depth of it. And then I can get the front face of the house here. Now this house is probably just going to go off screen, so I don't need to worry about the width. Again, the height, I don't know what height this is going to go up unless I go into my orthogonal line and or my guidelines, and I continue that across. One more guideline needed for this little floating edge here back to the vanishing point, and then I can use this projected up here to find the rest of the shape of the house. So I've drawn this as though it's maybe the front face of the house here, and then this is the gable wall. The gable wall having this triangular kind of component to it. What if this was flipped and I draw this as the gable wall and this is the front face of the house? How do I calculate the triangular point of the gable wall accurately in perspective? We do it exactly the same way we calculated this wall here. We just find the center point of the wall in perspective by clicking on the corners to draw an X. This is now the middle point of our shape in perspective there. So from this center point I can project up, and then I can find the height of our roof here. In fact, I can't do it that way. This is going to get a little bit complex, but what I need to do is find the center point of this building, which is here for that bottom face, project up to meet the ceiling, and then project across, and that is the center point of this building, and therefore also the center height of that building at that point. That's a wee bit more complex, but that's only if we want to be super accurate, and that's because this point is disappearing backwards in space. You know, the height of the house, it looks like it's getting lesser as it disappears into the distance there. Okay, so I'm just going to finish off that roof part here. And that's our gable wall drawn accurately in perspective, receding into the distance. So there's two houses that are identical, just facing in different directions down the street. Now I'm going to go ahead and add a few more details in, like the footpath and the road surface, just to give this a little more shape so it looks like a street. One of the great things about using Photoshop and digital drawing tools is we can sort of cheat by making selections like this. Control C to copy, make sure we've got the right layer selected, Control C, Control V to paste, and you can see I've done this on the other side here, and then I can use Control T or my free transform tool to transform this down so that it matches my perspective grid again. And I'm just going to move this backwards in perspective here, and you see if I place that there roughly and then erase out some of the overlapping lines, I have the same house duplicated fairly accurately in perspective there. Another thing that will help give your drawings the illusion of depth is the fact that this is just because I've duplicated these, but I could use a smaller brush, and you see that it looks like these things are receding into the distance just because the line weight is lighter as they go backwards in space. Now, it's unlikely that designing suburban streets is something that excites you. We're going to be spending more time designing, fantasy, sci-fi scenes, objects, people, vehicles, weapons, and things like that. And you're going to be focusing a lot more on style and themed content, shapes, color theory, all of that kind of stuff. So you don't want to get bogged down in drawing grids, but I'll show you some applications of this. So here, for example, in Cyberpunk, we can very clearly see the lines leading back to a vanishing point in the distance. This is actually drawn in 2-point perspective. There's 2 vanishing points. Here's a great piece of concept art from World of Warcraft Legion, and the most interesting thing in this scene is not the perspective, it's the shapes, it's the architectural details, it's the colors that have been evoked in the scene. But you can see that the 1-point perspective that's used here for the road leading up to this building just helps to create a sense of place and realism in the environment. Here's a few more concepts from Riot Games from West Studio here on ArtStation, and you can see the really strong sense of perspective that they have in all of these drawings. So you've not been introduced to this so that you're a slave to perspective and the grid, but it will be really helpful, even if you're drawing quite loosely over the top of a grid, to be able to approximate the position of objects within your scene. Then you can get to the fun part of painting up the environments and making them look good for your animations or games. So we've had a comprehensive look at exterior scenes. Let's see how this perspective is applied to an interior scene really quickly. So I'll just deconstruct this scene. The first thing that I started with was my horizon line, which I drew quite high up because I wanted to be looking down into the scene towards the floor. There's not much going on in the ceiling of this scene. The next thing that I drew were all of these orthogonal lines, and then I just recessed them into the background by lowering the opacity of that layer. And then I wanted to establish the back wall first of all for how deep this scene was going to be. So I just drew a simple square here, or a rectangle here, and that defined the back wall of this scene. And from there, this is just the inside of a big cube, like the cubes that we've drawn before. You're just not going to be able to see the front face of it. So it's like we're inside the cube. So I can just grab these edges here, and using the orthogonal lines as guides, I can project those out to the corners. Now obviously we are not going to be we're looking through the wall, or we're inside the room is the perspective that we're at. And from there I just established the shapes of the doors of the different elements that are inside of the scene. Now perhaps the most important thing, and this applies to exterior and internal scenes, is the scale of the objects within your scene relative to the vanishing point here, or rather the horizon line and the vanishing point. The height of objects relative to the horizon line here is going to determine eye level in your scene, or the camera level in your scene. So let me explain that. Whenever a person is standing within this room, I want the person to be somewhere about here in height whenever they're standing on the ground. And that means that their eye level is going to intersect the horizon line. So I've chosen an appropriate height of the room to ensure that a person can walk comfortably within it, not bang their head on the door whenever they're going through it, for example. Okay, so it's important to think about the height of a person within your space. Now, in my exterior scene, it's very clear that my camera's eye level is not eye level for a human. It is higher because you can see that the horizon line here is right above this door. That means that if I drew a person with their eye level being at this height, they would be extremely large. Okay, so I've not represented realistic eye height. This camera would be way above someone's head, a couple of foot above someone's head, as we can measure from the door here. So when you're creating a game or animation, why does the horizon line level relative to the characters even matter? Well, this is particularly important in animation. Look here at this scene, which is meant to be very relatable. And you can see if I turn on the orthogonal lines in the horizon line, it goes through their eye level. The horizon line is at eye level, and that helps make this scene relatable because the camera looks like a person standing in the scene. It's like you're actually there. Consider this scene, and the horizon line is really easy to find because it's going to be along the ocean, and this high horizon line above the character's eye level creates an epic feel. The camera is obviously not at the same level as a person standing on the plane that these characters are standing on. It's far above their heads, and it creates an epic sense of the scene that's around them. It makes the characters feel smaller. Conversely, sticking with Arcane as the example, this scene has a horizon line at a very low level by comparison to the character's eye level, and this makes the characters look large, looming, and intimidating. So the position of that horizon line can really have a big impact on the feel of the scene. So I really hope that was a helpful introduction to drawing perspective scenes for you, and that soon you'll be able to draw in perspective without even realizing it. You'll be able to maybe draw a couple of guidelines and then just freehand draw the rest of your scene around that.